Good morning from Santa Cruz. Today we're going to work on trigonometry, and there's not very much trig on the test, and there's basically pretty much, well, maybe two concepts I want to tell you about trig, and that's it. So let's dig in. So trig always deals with right triangles and the relationship of the sides and the angles. So the first concept that you may remember is Sohcahtoa. And you definitely need to know this for the test. Sohcahtoa is a way of remembering what sine, cosine, and tangent are. And so we have stands for sine, opposite, and hypotenuse. So this means that sine is equal to the opposite side over the hypotenuse. Ka is cosine, which is equal to adjacent over hypotenuse. And toa is, let's do it in blue. We've got tangent equals the opposite side over the adjacent side. Now, you need to memorize this unless you decide that you're not going to do any of the trig problems. And that is your decision to make. Let's make this a little bit more legible here. I don't know if that helped. Okay. Anyway, it's pretty easy once you get to know this. So if you can memorize Sohcahtoa, it's well worth your while. Okay, so the first question that I want to do is, let's see, test 1, section 3, number 19. So let's go there. And they tell us in a right triangle, one angle measures x. Well, there is no right triangle, so we're going to draw one. Whenever there's no picture, we draw one. We have one angle measuring x, where sine of x equals 4/5. Great. Sine of x equals 4/5. Now we just set up here that sine is equal to the opposite side over the hypotenuse. So sine of x means we stand here at x. The side opposite is 4, right, our numerator. And the hypotenuse, which is the side opposite the 90-degree angle, is 5. So that's what we have. They're asking us what is cosine of 90 minus x. So the question is, what is 90 minus x? What angle is it? Let's talk about it. We know that a triangle has 180 degrees. And if you don't know that, you need to know that. It's also given in the reference information in the beginning of every section 3 and 4. So, is it fair to say that if we already have our 90-degree angle, let's just label this angle for our purposes here, that angles x plus y are also going to be equal to 90 degrees, because 90 plus the 90 is the 180. Now we want to find out what 90 minus x is for our problem. So let's subtract out the x, and we get y equals 90 minus x. So what they're asking for here is really cosine of y. So let's look at y. We're going to stand at y, and cosine, as we know, is the adjacent side over the hypotenuse. Well, the adjacent side is 4, and the hypotenuse remains 5. So check it out. We've got sine of x is 4/5, and cosine of y is the same thing. What's the takeaway? Sine of x equals cosine of y. And this is true anytime x plus y equals 90 degrees. So now I want to tell you I want to give you some other circumstances in which this could be true, because it's obviously true in a right triangle. But it could also be that, I'm going to work up here. Okay, it could be that instead of a one triangle, they split up the angles. So let's say this is X and this is Y, and they tell you that sine of X equals cosine of Y. Now, if this is true, then you know that X plus Y equals 90. Okay, so if they then tell you X equals 3X minus 1 and Y equals 5X plus 6, you can say, well, the two of them together are going to equal 90. And then you'd have your algebraic equation, which you then can solve for, which I'm not going to do here. This is just a made-up question. Okay, if you solve for X, you can get X equals something that you can also then get Y, because you know the two of them equal 90. If they ask you for X minus Y, right, you would know that. Okay, so that's one way to do it. That's another example of a question that they can give you. And if you know this information or this information, then you can do the problem. Okay, now let's see. There's one other more difficult problem that I want to show you. You may decide to do it, or you may decide, I don't know, I don't really think so. So they give you another right triangle, but the right angle is up here instead. And let's say this is A, B, and C. And they tell you this leg is 12. And then they say some point which is not shown is somewhere along AC. So whatever. So you say, and we're going to call it X. They say point X. And then they ask you, what is the value, check this out, of sine, well, let's see. Let's actually draw the line. I think it'll be easier to see. The sine of CBX minus the cosine of ABX. All right, I'm going to do this in colors so you can see. Excuse me. CBX is this angle here. CBX. All right, and then ABX is this angle here. They want to know what is one angle, the sine of one angle, minus the sine of the other. Well, we know, let me get back here, we know that CBX plus ABX equals 90 degrees, because this is our 90-degree angle. And those are the two angles that make up that entire angle. Therefore, sine of X equals cosine of Y. Well, if they're the same, then one minus the other, if this is true, then one minus the other is going to equal 0. If they're the same, let's just say they're 5. It doesn't matter what number they are. Let's say they're 5. 5 minus 5 is 0. So our answer is going to be 0. Okay, this is definitely a more difficult problem than the others, but I just wanted to present it to you because this is all the ways that I've seen that they could present this concept here, this concept right here. Okay, now I'm going to clear the decks, and there's one more problem that I want to show you, and this is a kind of it seems a little complicated. It's sort of a proportional, you'll see. All right, so we've got here, we've got a triangle within a triangle, right? We've got this big triangle here, and then we've got the small triangle there. They both share this angle. We'll call this B. Let's say this is A and C. So they share this angle here. They share B, and these lines are parallel. And well, I guess let's just read the question. Well, I'm making it up, so I'll just read it to you. All right, let's say it says tan of B is 3/4. And then we'll say, and remember that this is opposite over adjacent. Okay, so that's great. So we're standing at B, and the opposite is going to be either this line or AC. Let's just give these some letters too. So opposite of B is going to be either DE or AC. And the adjacent is going to be either BD or BA. Okay, let's read the rest of this, or I'll read the rest of this. Let's say it says the big hypotenuse is 15. Okay, so be very careful with how you label, right? You want to be really clear that you're looking at the big hypotenuse, not, if you put the 15 over here, it's going to look like BE is 15. So label it just like I am. And then let's say DA equals 4, right? So we can just put the 4 there. And then we want to know, what is DE? Okay, so this is going to be X. We now know, since we're solving for this, we're going to take this 3/4 and apply it to the big triangle. Okay, so opposite is going to be 3, and adjacent is going to be 4. Uh-oh. Well, this part is 4, so the whole side can't be 4. Okay, so listen, here's the thing to know. If the tangent is 3/4, you got yourself a 3, 4, 5 triangle. Now you need to know your special triangles, absolutely. So I want to just do a very quick review of the 3, 4, 5. So 3, 4, 5 looks like this. I highly, highly recommend that you be able to spot a 3, 4, 5 triangle. The thing to know about a 3, 4, 5 is that, or any special triangle, is that the sides don't literally have to be 3, 4, and 5. They could also be multiples. So you could have, for example, instead of 3, 4, 5, you could have 6, 8, and 10. But if you recognize that as also a 3, 4, 5, you can get your answers relatively quickly. Okay, so we know now that this side literally can't be 3, right? But it's going to be proportional to that. So we're going to take our 3, 4, 5 triangle, and we're going to multiply it by something. Now we already know in this, I'm going to just outline it here so it's a little bit clearer, okay? We already know that the hypotenuse is 15. So we want to get, and the hypotenuse is always the 5 side. If we put the 15 here, how do we get from 5 to 15? We multiply it by 3. So if we multiply the other two out, we got 3 times 3 is 9, and 3 times 4 is 12. So these then are the sides of our big triangle. It's a 3, 4, 5 triangle multiplied 3 times. So we have the 15. The smaller side, or the side that the 3 side, is going to actually be 9. So yeah, I'll put it in red. So this is going to be 9. And then our other side is going to be 12, which means that the BD is actually 8, since we know that DA is 4. Okay, so that's great. Now we still have to get to X, right? We're still trying to get this line here. All right, but now we finally know one of the sides. So we can do this 3, 4, 5 thing again. 3, 4, 5, we know that one of the sides, or the 4 side, is 8, which means we have multiplied everything by 2, right? Because 2 times 4 is that 8. It's going to get us that 8, which means that 2 times 3 is 6, and 2 times 5 is 10. We've got that 6, 8, 10 triangle here. So it turns out that our x is 6, and this side is 10. Okay, and then this side is going to be 5. But what we want to know is this right here. Okay, so understanding how your special triangles work is really important. So let me just go over this other special triangles that you should know. So 3, 4, 5. You should also know 5, 12, 13. Then these just are concerned with the sides of the triangle. Then there's 30, 60, 90, and 45, 45, 90. And those are concerned with the angles and the sides. Here we don't even care about what the angles are. Okay, so make sure you understand what these are, how to work with them, and that's it. Okay, my friend, I will see you next time. Have a wonderful day. Bye.